And so as I mentioned before, we have a touchscreen display, and everything's driven by icons. But we also have the conventional keypad back here, where you have your set key, your reset, the heat key for the tube heater, up down arrow. This is to open and close the wind protector. You can also do it manually. You don't have to do it that way. One thing I mentioned earlier, before I get into the menus and things like that, I mentioned different fiber types. So let me explain a couple of things pretty quickly. This fiber has 250 micron coating. You can see I've stripped the end of it. This is 900 micron tight buffer. So when I stripped the 900 off, the 250 came off as well. So that's bare glass. This is what I'm talking about with the loose buffer. Here's the strip fiber. This is 250 micron coating. Here's a 900 micron tube. But if you notice, I can move this through that tube very easily. So that can give you that problem where one of the fibers won't advance when you're trying to splice. But there's a solution for that. And in the case of the 70S, you have to remove the standard sheath clamp and put this one in. And if you look at it, this little bump right here on the rubber pad, see how the tip of my screwdriver has to kind of jump over that? That's because this protrudes downward and it pushes that 900 micron coating and the fiber down here. And so when I put this fiber in this clamp, and close it, now it won't move anymore. Okay, so this is a solution for the 70S, but we wanted to make it more convenient for the 90. So we did something a little different. So let me explain the clamping mechanisms. So here's the sheath clamps, and I can open and close these to put a fiber in here. There's the V-groove. You can see it's a very small blue ceramic V-groove. Here's my electrodes. And I'm going to zoom in a bit. So instead of removing the entire sheath clamp, which can be done, this screw and these two screws would be used to remove it. What I can do is I can push this little white thing. When I push this, this comes upwards and has the same effect as this kind of clamp for the 70S. So now you don't have to change your sheath clamps out when you get into the problem with the loose buffer. You just slide this to this position. But in that, so now you can see the white dot is aligned with the red. This is only used for that loose buffer. If we're dealing with anything else, regular 250 micron or tight buffered 900, we want to push it back in the other direction, like that. So the other thing about the tight buffer.
I have a question for you, sir.
Go ahead.
The sheath clamps in your Using two separate sheet clamps for demonstration purposes only?
Well, for the 90S, you don't have to change the sheath clamp. You just operate this switch.
Oh,
but we have this. This is new on the 90S. If you're dealing with the loose buffer fiber on the 70S, then you have to remove the standard 70S sheath clamp and put an optional loose buffer sheath clamp in it. So that's one of the advantages of the 90S compared to the previous generation. Now with a tight buffer, it is tight, so I can grab on this fiber and I can't pull it out of the 900 micron or the 250 micron. It's all one piece. Okay, so that was one of the features that I wanted to show you about the sheath clamps. The other feature, so there's this slide bar that's inside, and I can slide it to the loose buffer position or the position I'd use for tight buffer 900 or 250 or anything else. On the top of the clamp, there's another slide mechanism. Right now, both of these are in the yellow position. I'm going to slide this one out to the green position. When I open this one and it's in that position, this fiber retention clamp stays down. On the other hand, when I open this one, it opens with the sheath clamp. So this is what I was talking about before. If you want to use the full automation feature of this machine so that after you're done splicing, when it opens and the sheath clamps open automatically, you might want these clamps to be down so it's controlling the fiber and the fiber doesn't come out until you're ready. Okay, so that's mostly what I wanted to show you about the clamps. There's one other thing that I'll show you about the clamps when we do a splice. And I want to show you some other things about some of the accessories. So as I mentioned, well, actually, as I mentioned before, we can remove this sheath clamp by pulling this screw and this screw and this screw out. And then we can put this plate in here, and you can see it has these two guide pins. If we're going to splice fuse connect, we have to do that because we're going to be using a fiber holder system, and the holder for the fuse connect looks like this. There you can see the holes for the guide pins. Let's see if I can aim this a little better. There you go. And so the ferrule would be up in here. This is one from a fuse connect I already installed. You also notice it's got a little clamp here, and I have to flip that open after I've spliced the ferrule onto the fiber so that I can pull everything out of the splicer. Anyway, I'll show you that later. But in order to use this, I have to install this plate so I can drop it on these pins. Now you could put a plate on both sides, and in that case you can splice using fiber holders. These are for 250 micron or 200 micron coated fiber. These are for 900. When you're splicing fuse connect with 900 micron tight buffer, you can use your normal sheath clamp. However, this is 900 tight buffer. If we're going to attach the fuse connect to something like a 2mm cord like this, or the 3mm cord, those cords have the outer tube, then they've got Kevlar inside them, and then there's a fiber with 900 micron. In order to splice these, we have to use special fiber holders. This one is for 3 millimeter cord. This one is for 2 millimeter cord. And we also need a couple of other accessories. And I'll show you these later. This is for 2 millimeter. This is for 3 millimeter. But anyway, what that means is if we're splicing Fuse Connect to the bigger cords and not just to the 900 micron, we have to put the plate on both sides of the splicer. I'm not going to demonstrate that today. There's also some things you have to pay attention to in terms of cutting the Kevlar to the right length and that kind of stuff. I don't actually have some good sharp Kevlar shears with me, but if you're going to be attaching Fuse Connect to something like this, you need to make sure you have some nice sharp Kevlar shears, because you have to cut 35 millimeters of the outer cord jacket off, and then you cut the Kevlar to exactly 23 millimeters. So you need to make sure you get some sharp Kevlar shears. And then you would strip back 32 millimeters of that. That would leave only 3 millimeters of the 9 millimeter jacket. And I'll show you why later. Okay. Let's go into the menu system and discuss it. Now, as I was saying before, to operate the splicer, you may just want to use your keypad. I find that easier than pressing icons on the screen, but for menu navigation, it's much better to use these icons. And so let me explain some of the icons. This one here, the green one, is the same as the set button that's on the, it does the same thing as the set button here, and operates just the same as with the 70S or 50S. This is reset. This is also reset. This is the heat key, the thing that looks like the little splice protection sleeve. That's the heat key. This open and closes the wind protector, but you can do it manually. Up and down arrow, and when you're in the menu system, up and down arrows may appear over here so you can touch them with your finger. This little symbol right here, you can see it looks kind of like lightning with a plus down arrow. This is to calibrate the arc power. So I don't have to go in my menu to find my manual arc calibration, the one I've recommended you do every day before you splice. From the main screen, I can just press that, and now it's telling me to prepare and load left and right fibers. It's already opened the wind protector and is ready for me to load the fibers. And it's saying use G.652, 655, or 657 fibers. What it should really say is just use standard single mode, because that's what all these are. Actually, this is standard single mode. This is bend-in sensitive single mode, or the BIF fiber. And this is NZD fiber, which is a long distance fiber. But all of them are single mode, and they all have about the same melting characteristics. You can use any of them to perform the manual arc calibration. Okay, I'm not going to do that right now, so I'm going to exit out of here. This little X means exit. Now I'm back to the main screen. And there's some things you can see on the screen. That when you first turn the splicer on, this is kind of what you're going to see. It's telling me my total arc count is 125. Right now, I have the tube heater set up for a 60 millimeter sleeve, which is a standard sleeve. That is what you normally use for splicing. And that's a pretty big sleeve. For the Fuse Connect connectors, the sleeve may be much smaller. Like this is the one for 2 millimeter and 3 millimeter cord. You can see it's shorter. It's also shaped differently. There's actually some Kevlar in there and also a metal reinforcement rod. So we would have to change the heater mode to a different heater mode when we're installing Fuse Connect, and I'll show you more about that later. And depending on which fuse connect you're using, there's 3 different heater modes you might have to use, because depending on the design of the connector and, you know, whether it's 900 micron or a 3mm jacket, the sleeve is different, and we have to use different heating parameters. Now we're in right now splice mode number 2, which is SM auto. That's probably mostly what you're going to use. And what I told you before is if you're in an auto mode, it will look at the brightness of the fiber during the arc and determine if it's too bright or not bright enough. And based on that, it's going to reset the arc power and self-correct it a little bit before you do the next splice. So it's constantly recalibrating that arc power and keeping it close to the ideal heat output. What it's showing us over here is right now, by Bluetooth communications, we are paired with CT50 cleaver serial number 032424. We're set up for auto rotation. The battery status in the cleaver is good. When this gets low, you may have to replace the AAA batteries on the bottom of the cleaver. If we wanted to add another cleaver, we could press this, and if we have another cleaver available, we would press the link button. Let's see if I can get that to show up a little better. Anyway, it's this button right here. It's a little hard to read. I apologize for that. But you press and hold that for 6 seconds, and what would happen is that cleaver serial number will appear in here, and then you can press that position and pair it with the splicer. So it's real easy to set this stuff up. I'm going to exit out of there. Okay, so that's some of the information on this screen. Also, you see up here, it says 60mm single. That's indicating the heater mode. And this is indicating we're in mode 2 SM auto. I can press right there and go into my splice mode selection menu. We're in SM auto. If I was splicing multi-mode fiber, I would choose multi-mode auto. And there's a bunch of different modes in here. Probably all of them you'll never use. This auto mode right here, this takes a little bit longer to splice than SM auto or multi-mode auto, because first the camera system is going to analyze what the image looks like and determine, is it single mode, non-zero dispersion shifted single mode, dispersion shifted single mode, bend insensitive fiber, multi-mode, what is it? And after it determines that, then it knows the proper heating conditions. Now, most of these fibers, the heating conditions aren't very much different. But for multi-mode, as I explained before, we have to use a much longer prefusion time, and we're going to trap an air pocket and get a bubble because the core is going to want to melt back at the beginning of the splice. Down here, you see SM fast. It is a little faster than this mode, but we don't recommend you use it because this is still plenty fast. And you've got plenty of other things to do when you're splicing. There's the heat shrink time. There's the time to prepare, strip clean, and clean the fibers. So you don't really gain anything. And what you lose is this does not use the glowing fiber image to recalibrate and use that auto arc calibration. So you're really better off using the auto mode. And you're probably best to use SM auto for any type of single mode splicing and multi-mode for multi-mode splicing. There's also a whole lot of different modes down here. At some point in the future, maybe you would have some need for these. If you wanted to do an attenuated splice, there's lots of different attenuated modes. There's different modes in here for different types. This is for splicing an 80 micron fiber to a 125 micron fiber. This is for splicing 80 micron fibers together. These are different fiber combinations. So there's a lot of stuff in here. And one of the things that you see in here is SM to SM. That is kind of a catch-all mode for if we have some kind of new type of single mode fiber we want to splice. And you see the little pencil here? If you press that, it allows you to come in and edit it. And the first thing you see is just some titles and stuff like that. But in SM to SM mode, we've got a lot of flexibility to do some really interesting things. For example, in the alignment, we can determine and we can tell the camera what focus position we want to use. Normally in SM Auto, what it's going to do is it's going to move the focus in and out a little bit to find a really good image, that really good sharp peak in the center of the bright area. But if we're just splicing two fibers together that are a little and we're going to only be splicing those exact same two single mode fibers, we may want to speed up the splicing time a little bit by setting it to a specific position. Or we may need a position that it wouldn't normally find when it does its search routine. Anyway, we're doing core alignment, not clad alignment. This is where we can control the prefuse time and power. On the arc, main arc, we can actually pulse it on and off. So this is some pretty exotic capability. I don't think you guys will ever need it. What I wanted to show you about this is now if we go up to SM Auto and we go in there to edit those parameters, you're not going to see nearly as many parameters. So here's the arc, and it says the arc power is auto and the arc time is auto. Well, why does it do that? Because this mode has been designed by the factory to work in conjunction with that auto arc calibration and keep everything in the sweet spot. So you don't want to go in there and change the power and the arc time because the automatic calibration is controlling all of that for you. Okay, we can go in here and look at error limits. You could decide that you don't want to accept a cleave angle as high as 3 degrees, but usually for splicing single mode fiber, that's okay. Cleave shape error is normal. Loss limit is 0.2. The reality is, if I get an estimated loss from the splicer and I'm splicing two single mode fibers together and they're not something really exotic where one of them has got a really small core and one of them's got a really huge core, then I'm going to expect my splice loss estimation to normally be 0.0, 0.1, 0.2. If I have an occasional 0.5, 0.5, 0.6, maybe even a 0.7, that's okay. But if I start seeing 0.1 dB or 0.15 or something like that, something's really wrong. You shouldn't be getting really high estimated losses like that. And if you start seeing that, you need to investigate, maybe get on the phone with us. This is showing the fiber angle limit. That's the angular misalignment that it will tolerate before you get an alarm. 1 degree is very generous. To be honest with you, if those blue ceramic V-grooves, if you're keeping those alignment V-grooves clean and there's no dust or coating debris in there, usually the fiber angle is going to be 0.1, 0.0, 0.2. If you start seeing 0.3, 0.4, then I'm going to want to look at those V-grooves and see if there's some dust in there. Here it's saying the bubble sensitivity is standard. Remember, there may be some fiber combination that you'll splice in the future where maybe some manufacturer introduces a new bend-in sensitive fiber, and when you splice it to single mode fiber, there's such a big shadow on the splice point that you might want to reduce the sensitivity of detecting the bubble, because it might, that black line at the splice point might be so dark or so big that it's telling you a bubble when really all you're seeing is the difference between the left and the right fiber. You could come in there and adjust that. The stripper parameters are meaningless because we're not going to have a Bluetooth connection to a stripping tool. You're going to use some Miller strippers, or the splicer comes with these blue handled strippers. And one thing about the blue handled strippers, you notice there's 3 little grooves. The smallest groove right here is for stripping 900 or 250 coating. If you have a loose buffer fiber and you want to strip that 900 off and leave the 250, use the second slot. And if you've got something like a 2 millimeter cord and you want to expose the Kevlar, you use this slot. And now your Kevlar is exposed, and you can get down to your 900 micron coated fiber. So that's why there's the 3 grooves in this stripping tool. Your standard Miller stripping tool doesn't have all that capability. It's only got the 1 groove where you can strip 900 and 250. So you may want to take advantage of the tool that comes with the machine. But everybody's got their preferences on hand tools. Okay. So anyway, that's some of the things in there for SM Auto. All right, let's get out of this. We're back to our main screen. And if we touch this, we can go into the heater menu. Right now, we're in a mode for a 60 millimeter sleeve. That's this big sleeve here that we use for standard splicing. If we were going to splice a fuse connect, there's maybe a couple different types of sleeves we might use that come with the fuse connect kits. And if we go down here, this mode is for fuse connect. It says fuse 900, and underneath it, it says SC, LC, ST, and FC. Sam, Charlie, and LC, those are the 2 connector types you're going to use. The LC is the smaller one. And if you're doing any of these fuse connects with the 900 micron jacketing, the sleeve you're going to use is pretty small. Here's my standard 60 millimeter splice sleeve. There's the one I use for the 900 micron fuse connect. So it's really small, and we have to have different heating conditions, and we need to use this mode. If we're splicing the 2 or 3 millimeter jacket with the Kevlar in it, then our sleeve is this thing, which is not as big as the 60 millimeter sleeve, but it's much bigger than the one for the 900. And depending on what you guys are using, let me exit out of here. You may need to use this mode or this mode. If you're splicing a fuse connect with a 2 millimeter or a 3 millimeter cord with a SC connector, you would use this mode. If it's the LC connector, you would use this mode, regardless of whether it's 2 millimeter or 3 millimeter cord that you're splicing to. This is an ST connector, FC connector. I don't think you guys use any of those. You're just using the SC and the LC. Okay, I'm going to go back up here and reset this to 60 millimeter. You also see you could go in and you could edit the heating parameters, but I wouldn't recommend you do that unless you have some kind of problem, and you might want to be on the phone talking to us if you get into some issue like that where the sleeve isn't shrinking down properly. Let's exit out of there. Okay, this little icon here that looks like a house takes us to the main menu. It's kind of the home key. If I press splice operation, I go back where I was. I can, before we press down here to get into the splice mode menu, but from the main menu, I can press here. And now I'm in my splice menu where I can get it to SM Auto or multi-mode. But again, you don't need to do that because you can do it from the main screen by just pressing here. Let me go back into the main menu. The same thing with the heater menu. This is memory. So every time it does a splice, it saves data in memory, and we can access that. And let me just go into this splice here. This was done with SM Auto. And when I go in there, I'm seeing the splice results. I'm going to look at another one. Let me look at this one right here. Okay. So anyway, this was done with single mode auto mode. It tells you the date. There was no error. The estimated loss was 0.03, so there's probably a little bit of a problem with that splice, but not bad. That's okay. Before the splice, the cladding offset was 0.7, and after the splice, the cladding offset was 0.5. Before the splice, the core offset was 0.2, but at the end of the splice, it was 0.0. So you might be wondering, why was the core better aligned after the splice than it was before? Well, the reason is the splicer looked at the image of the fiber. It could see that the core was not centered in the fiber. And when you arc the fiber during the fusion arc, if you offset the cladding, it starts to come into alignment. So in that case, we're going to offset the cladding a little bit more. So when the cladding self-aligns because of the heat of the arc, the cladding self-aligns a little bit, but not completely. And that brings that, so we've deliberately offset the cladding a little more than we need to, which means the core is offset, but at the end of the splice, the core is aligned. So what I'm showing you is a core alignment splicer is very, very sophisticated in terms of what it does. Now, because we had to misalign the cladding and then it self-aligned, there was probably a little bit of core smearing. Remember, I said the optical system can not only look at how well aligned the core is, but it can also tell if there's any deformation or any curvature anywhere down the length of the core. So it saw something that caused it to estimate a 0.03, which is still a good splice loss. Okay, so it's also showing you the cleave angle data. The left cleave angle was 2.2, the shape was okay. The right cleave angle was 1.6, the shape was okay. The fiber angle started out at 0.2. That's the relative angle between the two fibers. At the end of the splice, it was almost perfect. Here's the settings that were used to splice it. It was in SM Auto, which means that the arc and the arc time and power were on auto. Here's the error limits for the splicing mode that was used. I'm going to go past the stripper. Here's the cleaver that was used. That was the cleave count at blade rotation position number 4 when this splice was done, and it was on the lowest blade height setting. So there's a lot of information in here. You may not use this, but I wanted you to know it's available. And if you had an error and you wanted to come back and find out what happened to that splice, you can just look at the splice result of error. And here's a multi-mode fiber. It's not completely surprising to me that the error that occurred was a bubble in the fiber, because that's, you know, if your prefusion time is wrong, that can happen. But anyway, that's just to show you what's in the memory menu. Down here is the little help guide that I told you about. So the first section is features introduction, and there's all these different things that we can select to go into explanation of, for example, automation of the wind protector. So now it's showing us a little video that shows the automation of the opening and closing of the wind protector. Let me get out of there. And let me exit out of there. Oops, sorry. But there's all these different subjects you can pull up. And then we can go down to the power supply and find out about batteries and AC and DC batteries. Go into the splicer and heater mode, find out about that. The next item is splicing with the sheath clamp. So if we're using sheath clamps, we can do that. If we want to try to find out about splicing with the fiber holder, we go there. And then here are the things that it talks about for daily checks. Here's explanation of the maintenance menu. Next one is explanation of the setting menu and explanation of other things. Okay, so that's all the stuff that's in the guide. So as I said, you can download the manual by connecting a USB cable to the splicer and print off the complete manual, which is way over 100 pages. But a lot of stuff that you might commonly want is all going to be in here. The splice settings menu, the first thing in there is fundamental settings. This is where we set up our automation. Right now it's in auto left right, and that means that when I load the left and the right fibers in the splicer and have closed the left and right clamp, it automatically closes the wind protector, performs the splice, And then after the splice is done and it's estimating the loss, it automatically performs the pull test to check the strength of the splice, opens the wind protector, and opens the sheath clamps. So especially if you're using those little fiber retention clamps, you may want to set up the splicer that way, because the fiber retention clamps will keep the fiber under control, even though the wind protector and the sheath clamps have opened. And then you can, whenever you want to, you grab the fiber, slide the sleeve over the splice, put it in the tube heater. But if you don't want to use that operation mode, you can go in here and select whatever you want. And like I said, they range from all the way to manual, or I might want to customize it, in which case I've got all kinds of new parameters to play around with in terms of how I'm going to customize it. I'm going to go back and set it on auto left, right. Let me exit out of there. Oops. Okay, the next settings are for the heating menu. So I could put a closed cover time. Right now that's off. But if I put a time in there, if I'm not working with the splicer and doing something and it's idle and I walk away from the splicer, after that time period, it will close the tube heater just to make sure no dust or anything gets in there. Right now, the automatic functioning is on. If I turn that off, then I have to use this little key to open and close the heater and start the operation. Fiber image in the screen. I can, for any stage from the beginning, for when it's first setting the gap between the fibers, when it's aligning the fibers, during the arc, during the estimation, at ready state, at pause 1 or pause 2, which I can turn on or off, or when it's finished, I can show the X or the Y camera image or both. This is where I can determine if I'm going to ignore splicing errors. The reality is, if you have a high estimated loss, a bubble, a fat splice or a thin splice, if it's too fat or too thin, you may have some kind of problem. If it's too thin, maybe the arc is too hot. If you have some dust burning, it could have been there was some coating debris on the fiber, and you'll need to do a little better job cleaning the fiber the next time. If you've got a bad cleave angle or cleave shape, or a fiber angle, I would not override those. I would instead re-prepare my cleaves, and it'll tell you whether it's the left or right cleave, because if the cleave angle is really bad or the cleave shape is bad, it could have an effect on your splice loss. Other splice settings, number of re-arcs that can be done after the splice. Remember, I told you, if you're trying to figure out if there's only a little black spot and it's not very big and it's only in the X image and the Y image, but you have a bubble error, you may want to re-arc to figure out if that's actually a bubble or not. If that little spot gets a little smaller when you re-arc, it's probably just a defect on the surface and not a bubble inside the fiber. Anyway, there's a lot of different parameters. I'm not going to explain every one of them in the interest of time. Let's exit out of here. Other settings. This takes us into a whole submenu, the supervisor settings and the menu lock settings. This is stuff that David might use to exercise some control over the way the splicer is used. Machine settings in here. I can determine what language is going to be displayed, the volume of the little buzzer, the monitor position. Right now it's on auto. So if I have this monitor tilted down, it shows in one direction. If I had it tilted up because I was going to have the monitor at the back, notice it just flipped around so that if I had this monitor on the back side of the splicer, I'd be looking at it in this direction, and I want the text to be like that. Let me tilt it back down. You'll see it flip back the other way. Right now I have the V-groove illumination off. If I turn it on, you can see that light came on, and that helps you see what you're doing in the V-grooves when you're loading the fiber. I'm going to leave it on for right now. And there's a bunch of other machine settings in there. These are to, if you're operating on battery power and you're not plugged in with an AC cord, then what you may want to do is put some of these, turn some of these features on and set the timing. And what this will do is if you walk away from the splicer and it's idle for a while, you can cause different things to time out and go to sleep, so you save some of your battery power. So that's what all that is about. This is just about titles that can show up on the screen when you turn it on. Electrode, right now, after the way it's set up from the factory is after 5,000 arcs, it's going to give you a caution that you're running out of electrode life. After 6,000, it's going to remind you, hey, you probably ought to replace those. So again, there's a lot of different features in here. Cleaver blade alarm. Normally, I would have these on. So if it's going to change the blade position, it will tell me. Or if it's going to change if it's going to indicate to me that I should change the height. So normally I would have these on. Actually, it's blanked out right now. It depends on the automation feature that you select elsewhere, what capabilities you have on some of these. Let's go down here further. Arc calibration, the cleave angle limit that's acceptable for arc calibration, it's set at 2 degrees. I would leave it there. I would recommend you leave it there. Right now, the maximum number of tests is 2. Remember I said, when you do that manual arc calibration, if it has to make a big correction to the power or a big correction to the center brightness gap set position, it'll tell you to do the arc test again. And if it has to make a second big correction, it'll tell you to do it again. So you could set that all the way up to infinity if you wanted to, but 2 is a reasonable number, because if you've done a couple of tests, it's going to be pretty close to the ideal power. Okay, here's our Bluetooth settings. You can see we're paired with this cleaver, and we're not paired with any stripper because we're going to use some kind of hand stripper like the blue-handled stripper that came with the machine, or maybe some of these Miller strippers. All right, let's exit out of there. Cleaver settings. What it's telling me here is right now the cleaver blade is at the lowest height setting, the low number 1 setting, and the rotational position is number 4. Now, in terms of how the blade rotation is linked to an alarm, it says auto with confirmation. I could possibly change that. My selections are manual. Auto with confirmation means that the splicer can issue a command to automatically tell the cleaver to rotate to the next position, but it's going to tell you about it first, and you confirm that it wants to do it. If you set it with auto without confirmation, it's just going to go ahead when it judges the blade should be rotated and rotate it, and you're not even going to know about it. So you would probably use one of these. Manual means that it will maybe tell you when it's time to rotate the blade, but you have to do it manually. Okay. So that's most of what's in there. Let me exit out of there. So we've covered splice settings, other settings. Let's go into maintenance. This is very important. So here's our arc calibration once again. But remember, if we go all the way back out to the main screen, I can go directly into the arc calibration by going for this icon right here. But let me go back into the maintenance menu. The second thing is diagnostic test. I'm about to do a diagnostic test. The diagnostic test is going to check LED brightness. It's going to check for dust on the cameras or lenses. It's going to calibrate both the motors and the arc calibration. Oops, sorry about that. So it's going to do 2 calibrations. It's going to do this motor calibration and the arc calibration. and then it's going to check some other stuff. You can do the dust check individually. This is the stabilized electrode thing that I told you about. So if you have unstable electrodes, you can go in here and press this. It's going to tell you to load fibers. You strip, clean, and cleave fibers like you would for splicing. And what it's going to do is splice and arc multiple times and try and build up some silica deposits on the electrodes, which hopefully will then make that electrode condition good. And you would want to, after this, do an arc calibration and make sure it's okay. So sometimes if you've accidentally touched the tips of the electrodes, you can get it to function properly by doing a stabilization. It won't always work. You know, if you've really damaged the tip of the electrode, then you're just going to have to put new electrodes in them. When it comes time to replace their electrodes, what I would do is go in here, go into this, and it's going to tell you replace electrodes. It tells you turn off the splicer, replace the old electrodes with the new ones, turn it on. When you turn it back on, it's going to tell you to load left and right fibers in there, so you prepare them just as if you're going to splice. It does the arc stabilization. Then it tells you to load a new pair of fibers in there. It does the arc calibration. After the manual arc calibration is done, you're ready to resume splicing with your new pair of electrodes. So I'm not going to do this right now, but I do want to show you one thing. The electrodes that you see here are built into a little assembly, and this thumb screw allows you to pull them in and out real easily. So you just loosen this by hand, and the electrode assembly pops out. And so that makes it real easy to put new electrodes in there without damaging the tips. And you get, when you get a set of replacement electrodes, you get 2 of these. You always replace them as a set. You never replace just one. So it's much easier to remove and replace the electrodes on this machine than on our older ones. Let me go back into the maintenance menu discussion. So you can clear the arc count manually, but when you replace the electrodes, it will automatically do it. To clear the cleave count, so if you're using Bluetooth to manage your cleave life, you're going to go through all 16 positions at 16 rotational positions at blade height number 1. Then you're going to go to the next blade height and use up all 16 positions again. Then you go to the highest blade height, you use all 16 positions. At that time, the splicer is going to tell you it's time to replace the blade. The good thing about the CT50 cleaver is in the field, you can pull the scrap collector off and you can replace the blade yourself. You don't have to send it to the factory. The other thing that you can replace in the field is the complete clamp assembly, including both the upper clamp pads, the anvil, and the lower clamp pads. There's some instructions for doing that. And you pull this pin out, and then this entire hinged assembly comes out, and this cover stays on. You put the new one in, you put the pin in, and it's all pre-aligned at the factory. So if you ever damage the rubber pads or they get an indentation or something, again, you could just order one of these assemblies and you don't have to send the cleaver into the factory. While I'm looking at the cleaver, let me show you about this little roller here. This little rubber roller operates against this roller during operation to pull the cleave scrap into the scrap collector. And so once in a while, you're going to pull that scrap collector out. And if you pinch the top of it, you can hinge it open. And I have no scrap in here right now because in my previous session, I cleaned it all out. Hold on for just a minute. Let me see if I've got another cleaver here that has a bunch of scrap in it. Okay, this one you can see quite a lot of glass shards in there. This is okay, but when it starts filling up, it may interfere with the rollers pulling the scrap in there. So you're going to want to empty it out. And it's really, really easy. Just get whatever container you're going to use to dispose of your scrap. Turn this upside down and tap it. And now you can see that's empty. This is an anti-static coating on the inside of this, so it should be pretty easy to get that scrap out of there. The other thing, while I'm showing you the cleaver that I should show you at this point is, as I mentioned before, on the front of the cleaver, when it becomes necessary to raise the blade, use this thumb screw. If you wanted to manually rotate the cleaver blade to a new position, you can do it with this thumb wheel. But right now, you can't get to that thumb wheel because it's too far forward. The blade is too far forward. So to get that back to where you can use it, do that. And now you can see you can get to the thumb wheel. You can also rotate the blade with under battery power with the little rotate button. Here's your link button. And this is a battery charge indicator to let you know when the batteries on the bottom of the cleaver are getting low. It just uses AAA batteries. And you can use the rechargeable types or their regular alkaline batteries. It'll accept either one. Okay, so that's a little bit about the cleaver. This little plate here is a little different from the CT30, and this same groove right here is going to be used whether you're putting 250 micron in there or 900. And you can close this if you want to sort of hold it while you're cleaving. I tend to just leave it open and hold the fiber while I'm cleaving, but that is completely up to you. Whatever you're comfortable with is fine. So the other thing that's different about this with the CT30 is that since we have this blade height adjustment here, the way you set the cleaver blade to the starting position is by opening the cleaver completely. And if you look down in here, as I open this up, you'll see the cleaver blade moving forward. And this is telling me right now, it's on blade position number 4. But anyway, you can see that blade moving forward. So the starting position for the blade is all the way at the front. On the CT30, the way you cock the blade to the starting position is it didn't have this height adjustment here. There was a little slide assembly and you had to push it all the way to the back. And then you would operate the cleaver very similar to this one by pressing down like this. Now, when you press the cleaver, the top of the cleaver down, the first thing that happens is the top rubber pads close against the bottom rubber pads and clamp the fiber. Then the blade slides underneath from the front to the back, and then the anvil comes down and bows the fiber downward to propagate the cleave, and the scrap collector pulls it in here. So once you've got it in the starting position, everything happens by doing that. So a little different operation from the CT30, but very, very similar if you're familiar with the older cleaver. All right, let me go back to the maintenance menu. There's a couple of things I haven't shown you yet. If I use the down arrow, you see this is where you go if you want to discharge the battery to make sure you don't have a battery memory issue. Here you can drive the motors manually. And the reason we've had that in there where you can get to it pretty easily, if you get on the phone with the 800 number with our guys and you're trying to troubleshoot a problem, they may want you to move the motor around and tell them what happens when they tell you what they, to move it around, move the X motor, move the Y motor, move the focus or something like that. This one over here is maintenance issue info. So the other thing our service guys would probably ask you is what's the serial number of your splicer? What is the software version? They may or may not be interested in what is the total arc count. This is the number of arcs that this splicer has ever done in its life. This is how many arcs are on the electrodes that are installed right now. So this would be zeroed out when you do an electrode replacement. Down here, if you wanted to, you could set a date for the next authorized service. And what it would do is when it comes to that date, it would tell you to send it into AFL. Most people don't use that because the reality is if the splicer is working well, why would you want to send it in? And, there's no need for that. And if it's not working well, the first thing you're going to want to do is call that 800 number and see if we can fix it, find a way to fix it over the phone. So again, most people aren't going to use that. Oh, let me go back into maintenance. So what I'm going to do now is a diagnostic test. And so this is the test that I recommended that you guys should do probably once a week. I want you to do the manual arc calibration every day before you start splicing. But the full diagnostic test where it checks the cameras and all that stuff, if you do that once a week, that's usually enough. Now, sometimes when you call in on the 800 number, our technicians may ask you to do a full diagnostic check because then if they know what the results of that may help them troubleshoot the whatever problem you're having with the splicer. Okay, I'm going to go in here and do the diagnostic test, and you'll see this is the list of everything it's going to do. It's going to check the LED brightness. It's going to check for dust on the cameras. Then it's going to tell me to load fibers in it, and it will move the motors around to see how the fiber is moving to make sure the X, Y, and the Z motors and the focus motors are all moving correctly. It will use the same fibers you've loaded in for this to do an arc calibration. Then it'll check communications ports and memory. When I press the set button, the first thing it does is say, confirm that there is no fiber in the splicer, because when it does the dust check and the LED brightness check, we don't want any fiber in there to confuse what it's looking at. So I'm ready to go, so I'm going to press start. So now you're going to see that the brightness is going to change as it's checking and adjusting the LED brightness. And it's almost done with that. That passed, it's okay. Now it's going to do the dust check. And once again, we're seeing the X camera image here, the Y camera image here, and it's checking the entire field of view of the X and Y camera to make sure there's no big dust or anything that would cause a problem anywhere on the cameras or lenses. Now we're ready for the motor calibration. I happen to have already prepared one fiber, so I'm going to load it in there. I've still got to clean and cleave the other fiber. I'm going to open my sheath clamp. Right now, I have these clamps opening separately, so I had to open those manually. I'm going to put that in there. I don't know if you probably can't see where the tip of the fiber is, but remember the cleaved end needs to be beyond, halfway in between the inside edge of the V-groove, but not beyond the axis of the electrodes. I'm going to move this back over here, and I'm going to move this one back over. Okay, let me prepare my other fiber. And to prepare my other fiber, I'm going to show you my technique for cleaning the fiber. So first I'm going to strip it. Now, if we look at this fiber, those white specks that you see there, that's coating debris remaining on there. You can see a big piece there, there's a piece there. So I need to get all of that off. And my technique for doing that, I have a little kind of a ritual I go through. I take a Kim wipe or whatever type of cleaning cloth I'm using. I fold it with a Kim wipe. I fold it in half again. So now it's roughly an inch wide. Then I fold it in the middle to form a crease. And this creased area is what I'm going to get very wet with alcohol. So it's real wet here, and it's progressively less wet out here, and it's actually dry in this area. And then to clean the fiber, actually I'll back up a little bit. To clean the fiber, on my first cleaning pass, where I'm going to take most of the debris off, I'm going to put the fiber all the way down as close to this crease as I can. And you can see the way I'm holding this. I've got my thumb on one side, this finger here, my pointing finger in between. That allows me to open it and close it and apply pressure whenever I want. So again, this is my technique. So close to the crease, and I press pretty hard with my thumb and finger, and normally you're going to hear a squeak when you do that. Then I rotate the fiber a little bit to make sure I'm cleaning it all the way around, go for a second cleaning pass, and you notice that time I moved about 1/4 of an inch or 1/2 an inch away, and then the next time I'm going to load it up here, I'm going to rotate it again and clean it one more time. So that's my technique for making sure it's very clean. You can use any technique you want, but just make sure you develop a very good and consistent technique that gets the fiber clean. By the way, actually, I picked up a little dust somewhere, and I'm going to show it to you if I can. I don't know. I don't think you can see it, but there's a little spot there. So I'm going to clean that cleaver pad. So if there's dust on the cleaver pad, it's going to look white against the black background. So anyway, let me put my fiber in here. Oh, I actually cleaved that too short. I'm sorry. I had the coating up on top of the rubber pad. Let me grab another one. So if I'm cleaning my next fiber, I've already contaminated this part of the Kim wipe, so I normally fold it back in the reverse direction, and then I do kind of the same thing I showed you before. I'm going to do 3 cleaning passes in different positions while I rotate the fiber. So I don't know if you can see where well, I'm looking at the camera and you can't see where the fiber tips are. I'm going to zoom in. And if you look real carefully, you can see the ends of the fiber. Unfortunately, I'm at the maximum zoom, but if you look, you can see the left and right fibers extending in beyond the inside edge of the blue V-grooves, but not beyond the tips of the electrodes. So that's pretty much what you need to do. Okay. So I've got fibers in there and I'm ready to start. So what it's doing right now, this is the Y camera image, left fiber, right fiber. They're moving in. There's the this is the Y image, this is the X image. So it was checking that Z motion where it drives the fibers together. Now it's going to move this fiber in the X direction and this fiber in the Y direction. So the Y camera is watching how much this one moves. The X camera is watching how much this moves, because this is the Y V-groove motion, this is the X V-groove motion. So it's calibrating the Y motor motion. And now it's calibrating the focus motion. And you notice that as it changes the focus, it's moving the camera in and out, and the bright region gets big and then it gets very small. When it's very small, you don't see that peak in there anymore. And that's one reason we have to have a high resolution optical system and focus control, because otherwise we can't pick up that peak from the core. Okay, the arc calibration is now starting. So first it arcs several times and you can see it flashing. That was just to find the center brightness of the arc. So in other words, it determined the path of the plasma field from one electrode tip to another. Now it's offset the fiber by about 20 microns, splices them together, and it reheats and watches how much it self-centers in the X camera field of view. If it self-centers too quickly, the arc is too hot and it's going to turn the power down. If it self-centers slowly, then it knows the arc is not hot enough, and it will then increase the power. So it does a series of arcs. So this is that manual arc calibration that I told you to do once a day. And it's almost done. But you can see it's self-centered quite a bit, because when the glass gets hot, it wants to self-center due to surface tension. So we started out with a big misalignment here, and it's a lot less than it was at the beginning. Okay, so everything was good on the arc calibration. Now it's checking the communications ports, and that's done. Now it's checking memory. So the motor calibration takes a while. That's why we recommend you only do this once a week, because just doing the arc calibration by itself once a day, that's pretty quick. All right, we're done with that. I'm going to pull the fiber out. I'm going to do a quick splice, then we're going to do a fuse connect. I've got one fiber cleaved and ready to load. I'm going to put it in the splicer right now. Okay, I've loaded both fibers, and since I'm in that auto left-right mode, it's already, oh, I didn't get one properly in the V-groove, so that's a bad fiber position. That means I didn't do a good job of loading it into the splicer. So maybe we can see that if I open it. Anyway, I'm trying to hurry because we're getting late on time, so I apologize. Okay, that's more like it. That's a little score mark. That's a little score mark for the cleave, from the cleave. That's a little dirt because I'm in kind of a hurry since we're getting a little low on time. So I'm doing kind of a sloppy job. Anyway, the cleave angles are both 0.4. The cleave shape is okay. We've got a 0.3 fiber angle, so I may actually have a little dust in one of those V-grooves. I may need to clean that V-groove if I keep seeing that. We're at pause 2 because pause 2 is on. I could turn that off, and I didn't show you where to do that in the menu. I can show you that later. But anyway, we're going to go ahead and splice it. So I'm going to press the set icon, or I could go up here to the keypad and press the set button. So it's going to realign, reset the gap. That's the narrow gap. That's about 15 microns between the fibers. Now it's arcing. Where you saw the little bright spot here and here, that was due to where the cleave had happened. Now, if we look at this, you may not be able to see it, but the fiber has already popped upwards because I didn't have these little retention clamps holding the fiber down. They opened with the sheath clamps. Anyway, now I'm going to grab the fiber right here, and actually, let's see if I can get the, I'm moving the fiber around because I'm trying to put the sleeve on. Okay, so now the sleeve has slid down right against my thumb and forefinger, and I'm ready to just move it back and put it in the tube heater, put it in the center of the tube heater. Now, another way you can do it, if you don't do that, is put your 60 millimeter sleeve here, and then you can move the fiber back and forth to center it up, and then drop it down into the heater to do the heating process. I'm not going to do the heating process. It's going to close and do what it needs to do. Let's move on to the fuse connect in the interests of getting things done quickly. Okay, I'm going to do a regular 900 micron fuse connect. So first, let me show you the fuse connect package. When I open the package up, I've got some pretty good detailed instructions. You unfold this, and this is better than the PowerPoint. It tells you about accessories, what you need for different types of fuse connects. Here's detailed instructions step by step on how to do it. This is for 2 and 3 millimeter jacket. This is for 900 micron in this case. And there's some things in here about heater settings. We're going to have to update this because the 90S instructions for the heater settings are not in here. But anyway, this comes in the package. What else you see in the package is here's one of the polished, pre-cleaved fuse connect ferrules. It's underneath a little plastic cover, so I can't touch it right now until I pull this little cover off. I'm not going to do that until I'm ready to put it in the splicer. This is the connector body. Here's the splice protection sleeve. and here's the boot. So for 900 micron, first let me go back here, open this up. I'm going to have to remove this sheath clamp. And this screwdriver should be in your case. Okay. Now I'm going to put my fiber holder adapter plate in there. Notice this little groove, this little opening that goes over this. Tighten the screws. And you don't have to put a lot of torque on these, just snug them down. And I kind of get them semi-tight, and then I go back and tighten them a little more, snug them up. So I kind of tighten them a little bit and then tighten them the rest of the way. So now I can come back here to my package, and I am now ready to remove this cover, pull this out, and let me show this to you. So this is the little hinged clamp that we're going to have to open in order to get this out after splicing. The cleaved end, the stripped and cleaved end is out here. When we're done splicing, the splice sleeve is going to have to cover this small diameter part of the ferrule. The polished end of the ferrule is here, and there's a little tube on it. And we're going to use this tube and the fiber to pull it up out of the splicer V-grooves when we're done. Now, right now, what I want to do is just put this right away into the splicer so that it doesn't get contaminated, and close my wind protector to protect it. And next, I've got to get my 900 micron tight buffer ready to go. So I need to put my boot over the 900 micron, then put the sleeve on. And now, after I've done that, I can strip, clean, and cleave this and load it into the sheath clamp of the splicer. So if you're doing 900 micron, you don't need fiber holders. You will need fiber holders if you're putting the fuse connect on a 2 or 3 millimeter cord. So it's tight buffer. I got to strip a little bit at a time. Okay, so it's pretty dirty. You can see a lot of big dust spots on that. So I'm going to fold my Kim wipe the way I normally do. I'm getting it wet with alcohol. Use my normal cleaning technique. Now 900 micron has a lot of curvature. Look how curved that is. When I put it in the cleaver or the splicer, I want that curvature to be going downward. That gives me better control of placing it and making sure that everything is going to work properly. This splice sleeve is very short, and I'm going to want to make sure that after splicing that sleeve completely covers the bare splice area and also that little part of the ferrule that I mentioned before. So I want the bare fiber region to be as short as possible. With 900 micron, I'm going to get it as close as I can to this rubber clamping pad, but you can't have the 900 micron on top of the clamping pad or you'll have terrible cleaving results. Okay, so that's done. I actually had some dust on the end of that fiber. I may have taken this fuse connect out of the package. Oh, pardon me. You may not have seen it, but when the fiber first came on the screen, there was some dust on this cleaved end face. I think when I was practicing earlier today, I'd taken this fuse connect that's on the right side of the splicer out of the package and somehow got it contaminated. Okay, so we're ready to splice. We'll do that. Oh, there's a bubble in the fiber. So, you know, as I said, I had contaminated that cleave end face. So that's a perfect example of what I was telling you about. There you can see it. You see it in the X image, but not in the Y image. Now, if I re-arced, that probably is a real bubble because, as I said, I saw some debris on the end face of the fuse connect because I had contaminated it. So anyway, for the purpose of this demonstration, I'm going to go on and show you how to complete this. So let me go back here. Oops, wrong one. I'm going to open this. I'm going to get my splice sleeve close. Bear with me for just a minute. I have to, I've got a short piece of 900 micron and the boot keeps wanting to come off. So I'm going to put a little tape on the end of the fiber. Okay, so now I'm ready to take it out, and I have to protect all this while I'm doing that. So I'm going to press down on the fiber holder here, and you may even want to press down here and with your pointing finger, but grab the tube with your thumb and forefinger. And while you're doing that, open the clamp. So now you can see the ferrule. Now I'll open this clamp, and now I pick it up, and let's let the sleeve slide down. And it has to go all the way over this little small diameter part of the ferrule, like that. Now, right now, I am not in the proper heating mode. I'm in the mode for a 60 millimeter sleeve. So let me go in here, put it on this one, and now I'm ready to do the heat shrink process. And it's already closed and is heating. At this point, I can pull this out and throw it away, because it's a disposable temporary holder, and I'm ready to start my next process. While that is heat shrinking down, I'm going to talk a little bit about what's different about 2 and 3 millimeter. First of all, if you're going to deal with the 2 or 3 millimeter cords, you're probably going to need an extra accessory like this because you have to captivate everything so so none of it's moving relative to each other. It's kind of like that loose buffer fiber. So with this extra tool that you use, this one is for 3 millimeter. This one is for 2 millimeter. And now after I do that, I've got this bigger boot that actually has a spring in it that goes over here. And then this bigger splice sleeve, and this end goes on first. Oh, this is the one for 2 millimeter. I need the one for 3 millimeter. Pardon me. Okay, in the interest of time, I'm just going to talk through it. But anyway, you put that sleeve on with the narrow end first, and then you start to prep this end. And the preparation and the links are given in the instructions. And what you're going to do is you're going to cut this back 35 millimeters, and then you cut the Kevlar to a 23 millimeter length. And this isn't exactly that length. So here's your 900 micron. You cut this back 32 millimeters. That leaves 3 millimeters here. And then you have to use a special fiber holder, and you fold the Kevlar back. And again, I'm going to want my 900 micron down. The 900 micron goes in this little groove, and all the Kevlar and 3 millimeter goes in there. And then close the clamps. I haven't stripped this, but after this, the process is about the same. This one is